Hi everyone, thanks for coming along to the Southampton Excel user group. My name is Ben Weiner and I'm going to be presenting today on dynamic arrays in Excel. Just a bit about me. I graduated with a degree in history in 2008, so I didn't actually have any sort of technical or data background. But after graduating university, I ended up working in various finance roles from 2010. Going on to qualify as a CIMA chartered management accountant in 2018, using Excel heavily along the way throughout my finance career, and going on in 2022 to take the Microsoft Certified Excel Expert Certificate. And as well in 2022, I kind of transitioned away from accounting roles and more into financial analysis roles, where I currently am working in FP&A, which is financial planning and analysis, so doing lots of data analysis. As part of that, in my current role, I use dynamic arrays quite a bit to help automate a lot of processes. So you might have heard of array formulas before, which were kind of the traditional way of doing what I'm going to be showing you today. These were known also as CSE formulas because you had to press Control-Shift-Enter for them to work. And you could always tell if they were array formulas because they were surrounded by these curly brackets, which kind of stood them out as different from normal formulas. But these were really, really complicated to use. Not many people knew how to use them. And even if you did use them, depending on the complexity or volume of data you had, they could really slow down the performance of your spreadsheets. So they weren't very popular. The newer versions of Excel, though, has kind of a dynamic engine to it, which differs from the legacy version. And to explain the difference between the two, the legacy formulas and functions were designed to calculate a single value in one cell. They did not automatically expand to cover multiple cells. So it was a manual process if you wanted to cover a range. So for example, if you had data in A1 to A10 and B1 to B10, you'd need to do one formula for A1 plus B1 and then drag it down 10. Also, if you wanted to move your formulas kind of left or right or up or down and keep referencing specific things, you'd need to use the kind of absolute referencing either to a cell or to a column or to a row. So that's where you put the dollars in front of everything. And some of the legacy functions, people will probably be far more familiar with those than the dynamic ones, things like SUMIFs, VLOOKUPs, average, stuff like that. Dynamic Excel, though, you can actually return multiple values that spill over many cells by entering just one formula. They dynamically adjust to fill the required numbers of cells. So instead of doing A1 plus B1 and dragging it down 10, you could say A1 to 10 plus B1 to 10, and it would automatically fill down 10 rows. You've also got new functions that weren't around in the legacy version of Excel. So that would be things like filter, unique, and sort, which I'm going to go through today. And you can actually nest dynamic array formulas in each other to make them even more dynamic. So a few points on dynamic arrays. They're only available for Office 365, which is the latest version of Excel, and they're not backward compatible with older versions of Excel. So if you use a dynamic array and you send it to someone who's got an older version of Excel, they'll see errors when they open the file. There's a couple of new errors that are unique to dynamic arrays. So you all might have seen traditional errors like #NA, #ref. There's now a spill error and a calc error that I'll go through as we go through into Excel. And you can actually also make legacy formulas dynamic by using the hash reference to denote that you want the formula to spill. So again, rather than putting A1 to A10, you could put A1 hash and it would just fill down as far as it needs to go. So now that we know a little bit about the background of dynamic arrays, let's look at how they work in practice in Excel. So I'll just zoom in a bit so everyone can see. So the legacy way of trying to work out with this really simple little data set here, what the percentage of the sales price is, would be multiply the sales price by the percentage, and we get the correct amount of 44, but it's one formula that's showing in one cell. If I want to see this to cover the whole range, I'd need to copy this, go down to the bottom and paste it. And this is all correct, but each one of these are unique and not interdependent. So if I delete one, nothing happens to any of the others. If I type over one, again, nothing happens to any of the others. With the new dynamic engine in Excel, I can select the whole column and just multiply it by the whole column, hit enter, and it automatically spills down. So this is the first time that people have seen dynamic arrays. A few things to notice here. The spill area, if I click anywhere within the array, is highlighted by this blue box. If I click out, you wouldn't know that any of these were dynamic arrays. It just looks like it's giving you the correct calculation, which it has. But if I click in any of these, I can tell where my area starts and ends. Also, if I click in some of these cells, you can see that the formula up here is in gray, whereas the formula at the top is in black. So I can only actually edit this entire column by using the first cell that I inputted it in. So now I can change that to say C8. But if I try and do anything in these, it just won't let me. It just goes blank. And also, I can't delete these. If I try and delete one, you'll see they just kind of go for a split second and then they come back. This has worked because it's filled out the whole array area. There was nothing in here blocking it. If I was to have a value in here, so if I put again this times this, it breaks. We get this spill error. And that's because it's trying to spill down across this area, which you can see with the dotted blue line, but it can't go anywhere because it's being blocked. If I just delete that, it comes back and it works fine. This dynamic array is also locked in the range that I've set it. So at the moment, it will only go down to row 7 because I've selected B2 to B7 and C2 to C7. If I add something new here, like, 303%, happens, it doesn't go down any further because I've set it to look at a very specific range. A couple of ways you can get around that. You can, you could say, give it a range that is longer than your data set. And this way, if I now add 303%, it automatically changes from a 0 to a 9. Problem with this, though, is eventually, if I go past row 10, I'm going to have to remember to update my dynamic array. Also, I've got all of these zeros where there's blank data. You can get around the zeros by using an if statement. So I can just say, if my calculation equals 0, give me blank, otherwise give me the calculation. That tidies it up a little bit, but it doesn't resolve the issue of what happens if you go past row 10. So the way you could get around that is to make your data set a table. Just remove these at the very bottom. Control-T to make it a table. Now, when I select the whole range, rather than giving me, so if I start 1, 2, 3, it's going to say, B2 to B5, B2 to B6. When I get to the bottom, though, it gives me the whole table, which is table 1, and the sales price, which is the column. And I could just multiply it again by the whole area here. And as my table updates, this here on the right would update. You can't actually put a dynamic array in a table, but you can link it to a table. And also, you can't select an entire column. So if I said, just give me B times C, I'll get an error. That would have been handy if Microsoft had done that, but they haven't. So you've got a couple of workarounds. You can either go past your data set or you can make it a table. You also don't need to worry about referencing in the same way with dynamic arrays compared to legacy. So here, if I wanted to multiply 10 by 5, 10 and 15%, and 20 by the same amount and 30 by the same amount, I'd need to use the dollar signs in my formula. So I would want to say A3, where I lock column, multiplied by B2, where I lock the row. I can then copy, drag that over and paste it, and it works. We can see it's referencing all the correct areas. But with dynamic array, I can just say, give me that multiplied by that, and it's just going to spill across. And you can see here in the formula bar, there's no referencing in terms of the dollar signs. We've got the gray formulas where it's spilt over, and we got in the top left-hand corner, the initial formula we entered in black. And also, I can't delete any of these, but if I delete the one up there, everything goes. One thing to consider with dynamic arrays, though, is whilst the values spill down, the formatting doesn't. So if I was to say, I want this to be a currency, these are not filtered as currencies. And even if you select the whole range, say, let's make all of these currencies, and I add something here, 500 and 5%, and then I extend my dynamic array to go to B8 and C8, it's still not going to change the format of the bottom one. So you'd probably need to select, in this case, the entire column. If you only select a specific range, it won't extend that formatting for you. So now we've seen a bit about the difference between how legacy and dynamic Excel works. Let's look at some of the new functions in Excel. So first off, we'll look at the sequence function. You've only got one compulsory part that you need to enter, which is rows. These follow the same convention as legacy formulas. So anything in these square brackets is optional. So let's just enter at first, really simply 10 and bracket, close off the formula. And it just gives me the number that I entered spilling downwards. If I change that to 15, it goes even further still. I find this quite helpful if I know I've got I need to write 1 to 100 or 1 to 300. Traditionally in old Excel, I would have done that equals that plus 1, copied it down and kind of had to look in the top left-hand corner how many rows I was going down and paste it. Whereas now what you can just do is set your sequence or however many things you want to go down by, hold Control-Shift down, select it all, Control-C to copy, and Control-Shift-V to paste as a value. And now I've got a hard-coded fixed range here that I can use. You can also link it to a cell rather than hard-coding the numbering. So if I link this to 10, it will just dynamically increase and decrease as I change it. If we look at some of the optional parts of this formula as well, so we entered columns. If I say 3 columns and 10 rows, it's going to give me this little cube output, which basically goes 3 to the right, which is the columns I've selected, and 10 down, starting at the number 1, which it defaults to. But we can also break this up a bit by saying I want it to start at, say, 20, and it does the same, 20 going up in increments of 1. And lastly, we can change the increments as well. So I say start at 20, go up in increments of 5, 3 to the right, and down 10. So on its own, it's not maybe the most useful formula, but you'll see that when we integrate it with some legacy formulas or with the other dynamic arrays, it starts becoming really powerful. Next up is sort. I'll just zoom in a bit because it's a bit small here for some people in the room. Basically, we have a data set here on the left with some job information at various companies and locations with the salaries. And I've got the same headings over here on the right. Sort in its simplest sense, again, there's only one compulsory part and we can use it either on a column or a whole data set. I'll just show you on a column first. If I select my job titles, it's just taken that column and sorted it A to Z, which it defaults to. If that was numeric, it would default to sorting it lowest number to highest number. What I can do, though, as well is sort the entire data set. And now if we look here on the right, it's given me exactly what I had on the left, but it sorted everything from, by default, the furthest left-hand column, A to Z, or lowest to highest if that was numeric. We can start to build this out, though, because obviously the whole point of dynamic arrays is we want to be as dynamic as possible. We don't want to have to hard code or manually do things. So what I'm going to look at next is the sort index. So as a default, it sorts from the furthest left-hand column, A to Z. Let's say we wanted to sort by a salary column. That's the 4th column, 1, 2, 3, 4. If I type 4 in here, It's now sorted my entire data set by salary from the lowest to highest. And again, I could put -1, and it sorted my entire data set from the salary that's the highest to the lowest. What I don't want to do, though, is have to type in the number of the column I want each time and manually say whether I want it ascending, descending. I want to start linking this with other things to make it even more dynamic. So we're going to include a function here called xmatch. I'll just show you how that works outside of the data set first. So xmatch basically looks for something, which in this case is going to be job title, in a series or an array, which I'm going to use my headings here. And as job title is the first in this selected range, we're just going to see number 1. If I change this to salary, it changes to number 4 because, as we saw earlier, salary is the 4th column. So I can actually, rather than typing a number in here, put xmatch, say look up the salary in my headings here. Now my data is sorted by my salary, but if I change this to job title, it will sort it by my job title. If I change that to location, it will change that to my location. I can also, if I just put it back on salary, from my sort order, put an if statement and say, if this equals ascending, give me 1, otherwise give me -1. And now I've got my salary, and I can just change this to be ascending or descending. I could say sort it by location, descending or ascending. So this is how we can integrate things like if statements and xmatch into dynamic array to make it even more dynamic than its default settings. Now, there's a really similar function called sort by. And this is if you want to sort your data by a column that's not in the original array. And it can be handy if you want to hide something. So this obviously has salary data. If I wanted to share this with someone in a sorted way where all my jobs were sorted by salary, but I didn't want them to see the salary, I could go sort by, select these columns, and I want these to be sorted by my salary. And I could say as well, sort by, again by salary. And all this has given us is the same data as we've got on the left, but we don't have a salary column, even though we can see that it is sorted by that salary. And again, you could link this to drop downs using various other functions so that someone could still sort maybe by job title and location and even by salary, but they wouldn't see the salary in the data set that you put out. The next dynamic array we're going to look at is unique. So what you can do is basically select a range. Here I'm going to select my locations. And it's basically giving me the unique value of all of these cities. So you can see things like Bristol is there more than once. In fact, they're all there more than once, but we're only seeing them one time. The order that it's returned it in is just the order that it found everything first. So Southampton is last because it's the last time it finds the first instance of one. If I was to change this Manchester to say Liverpool, you can see automatically it's updated my unique values. And if Liverpool was after Southampton, it's going to stick Liverpool at the bottom. I'll just remove that. What's pretty useful with unique as well, if you use some of the optional features, you've got this exactly once option. So the default is false, which returns every distinct item. So you don't actually need to type that in. You could just leave it blank. But if I type true, it's only going to return Liverpool because Liverpool is the only city in this location that is there just one time. If I add Liverpool again, we get this calc error because it has no output that it can give us. So we get calc. I'll just change Liverpool back to Birmingham there. What we can also do now is start nesting our dynamic arrays within each other. So if you just use unique on its own, it does return the unique values, but in just the order that it finds it. So if I use sort and unique together, and I select my locations, it's giving me the same locations as above, but it's sorted it alphabetically from Birmingham to Southampton. And again, this will dynamically grow. So if I add Liverpool again, it's correctly put Liverpool between Bristol and London. What's great about the dynamic arrays is that they actually work with other parts of Excel. So if I want to use data validation to create a dynamic drop-down list linked to my data, I can select a list. And in my source, I'm going to select just the first cell and put the hash sign at the end of it, which basically says start in J10 and just spill down. Hit OK. My drop-down now has Birmingham, Bristol, London, Manchester, Southampton. But again, if I was to change this to Liverpool, in my drop-down, I alphabetically now have Liverpool between Bristol and London, which is its alphabetical point. We can also combine it with a legacy formula, which is count A. So if I wanted to know how many cities I had in my data set, I can use unique within count A. Oh, sorry, I need to put a second bracket at the end, and it's telling me 5. And again, if I put Liverpool in there, it will update to 6. So let's look at one more here, which is the filter function. This is the one that I find I use the most, and I think it's the most helpful. Again, in its simplest sense, we can just use it on one column. So I could say, give me all of the job titles where the location, equals Bristol. Now, if I change the location, it's just going to give me the job titles in the different cities. So it's just filtering based on that. We can also apply this to an entire data set. So I could say filter everything here. Again, where my location equals Birmingham, and I get my entire data set. Again, if I change the city, my data updates. The good thing about this filter function is you can actually combine it with and or logic, so you can build it out even more and get really specific. So if I say I want Birmingham and part-time, I can put the first part of my include in brackets, use the star symbol, which confusingly in the context of a dynamic array, star means and, it doesn't mean multiply. So I'm saying and, where my employment type equals part-time. So I need a second bracket at the end there. So now I can say, show me either full or part-time jobs in Birmingham. Again, what part-time jobs have we got in, say, Bristol? Full-time jobs in Bristol. And you don't just have to say equals, it works with greater than or less than. So if I was to also say, I want jobs in Birmingham that are full-time and the salary greater than or equal to £20,000. We can build this up. So if I now said greater than or equal to 60,000, it's removed the job that was 50,000. If I say greater than or equal to 80,000, we get jobs greater than 80,000. If I was to say 90,000, though, we're going to get that calc error because, again, there's no value for it to output. So a way around that is to use the optional part of your filter, which says if empty, which acts like if error does in legacy formulas. And I could just say no data found. And that way, if I say show me jobs 50K or more, I get these 3. If I say show me jobs 90K or more, I get nothing. Like I said, though, you can also use or rather than and. So what I'm going to basically say here is now I'm going to change this from a multiplication to a plus sign. Again, it's a bit confusing, but in a dynamic array, plus means or. It doesn't mean addition. So I'm basically saying I want all jobs that are either in Birmingham or full-time. Hit enter, and there you can see we've got this Birmingham job, which is part-time, but it still meets the criteria because it's in Birmingham. And then we've got loads of other full-time jobs, which are not in Birmingham. So really useful formula. I use that quite a bit, probably more than the other ones, certainly. Now that we've seen a lot of these formulas, let me get rid of this. Let's see how we can bring those together and kind of give a real life data set example, how we can combine them, nesting in each other and with legacy formulas to make a really dynamic data set. First thing I'm going to do is make my data set here a table. Control T, okay. I'm just going to name this table array data. This means that my dynamic arrays will update as the data set here updates. So the first thing I want to see is a list of companies in alphabetical order and just the unique amounts for full-time. So I'm going to say, give me the sort of the unique filtered companies, and I want these companies filtered where my employment type equals full-time. And there we go. So you can see if I change from full-time to part-time, I only have 4 companies. And we can see quite easily it's 4 and 5. This is quite a small data set, so it's quite easy for us to count. But if we wanted to dynamically have a list or a numbered list counting downwards, this is where we can use sequence that we saw at the beginning. So I can say sequence and count A. Again, just select the first value and press hash to make that count A a dynamic calculation. And now we've got 1 to 4. And if I change that to full time, we can see it's gone up from 1 to 5. Next, I want to know the location of the companies. So I'm going to use XLOOKUP, which is, again, not traditionally a dynamic formula, and it's a slightly more advanced or better way of doing VLOOKUPs. I'm going to say, I'm looking up this array. So I want K5 with the hash, and it goes down to the bottom. I'm looking that up here, which is the company name in my array data table. And I want to return my location, which again is not giving me a fixed amount. It's just giving me the whole location column in my array data. So that's spilt down. So this XLOOKUP is now dynamic, and we can see that because, again, these are in gray and we've got the blue box around it. We also want the total sum of all of the full-time jobs in each of these companies. Again, SUMIFS is not traditionally a dynamic array formula, but we can make it dynamic by using that hash symbol. So I'm going to say, give me the sum of my salary column. My employment type is full-time. And my company name is K5 hash, so it spills down. Also, I want the average salary. So I'm going to use average ifs, which also is not a traditional dynamic formula. Say, give me the salary, our employment type, full-time, and my company is K5 hash. So we've got here on the right all dynamic arrays, and we can see that because they're all surrounded in this blue outline, and it's going to completely update as I change it. So if I change this to part-time, it's gone down to 4. Change it to full-time, it's gone up to 5. What I can also do is if I was to add something new in here, so if I was to add a company called MNO Limited, if you keep an eye on this up here on the right, it's updated. MNO Limited is correctly in the alphabetical place between Global Ventures, Pioneer Technologies. Because I got the unique, no matter how many times I add that, it's only there once. I just add some new salaries here, say 30,000, 50,000, and 25,000. It's correctly known to do the correct SUMIF and the correct average if. And I can even go further, add in another company called ABC Limited. And again, my array on the right has updated. And if I change it back to part-time, because those new companies, ABC and M&O, didn't have part-time jobs, again, it's just dropped to 4. And it automatically included those. The last thing I just want to show you is how to have dynamic graphs linked to your dynamic arrays. Slightly trickier than you'd think it would be, but it's not too complicated once you've seen how it works. So first things first, I just want the sorted unique filter. Oh, sorry, unique chart. Yeah, that's correct. Unique, not unique chart. Sort unique filter. My locations, where the employment type is full-time. Has that not worked? Oh, because I need to put an equals rather than a comma there. Sorry. And we can see there are 5 full-time role or locations, but only 4 places have part-time. So we want to know the amount of salaries in these areas. So salary with the employment type is part-time and the location here. And again, I'm going to use the hash to make this dynamic. So that spills down. So we can see part-time and full-time, it correctly expands and decreases. So if I want to make this a graph, if I insert bar chart, at the moment it's correct. It's got Bristol, London, Manchester, Southampton, and their amounts. The problem is if I change this to full-time, it's updated for the first 4 values, but it's ignored Southampton, which is the 5th. And you can't, as we've been doing all the way through, just stick a hash at the end. So I can't say, right, just give me K4 hash, because when I hit OK, I get an error. So the way we need to go around this is just using named ranges. So if you go to Formula, Name Manager, new named range, I'm going to call this location, and I want it to be J4 hash. And OK. And I'm going to create a new named range and call this amount. And I want it to be K4 hash. OK. And close. Now I can go into my graph and select my data. Edit. I want to delete everything after the exclamation mark and write amount, which is the named range that I just made. And here I want to delete everything after the exclamation mark and call that location. Hit OK. Now it's including Southampton. If I say part-time, it just shows me the 4. If I go full-time, it shows me 5. And if I was to add a new value here, let's say Liverpool, my array here is updated and my table has automatically updated. And this would work again if I added, say, Brighton. The table just updates automatically. So this can be really handy for dashboards. One of the ways I use this is I'd have a hidden tab called Dashboard Calculations with lots of dynamic arrays in it linked to my data sets, and then the graphs on a dashboard tab. And that way, if someone maybe changes drop down on the dashboard tab, it will flow through to the dynamic arrays, which automatically update my graph. So that's pretty much dynamic arrays in a nutshell. Thanks everyone for coming, and yeah, thanks. Any questions?
Does the one do Power Query?
No, because
Power Query has its own equivalent.
Yeah.
A lot of this is actually taken from Power Query.
Yeah.
The logic of it, so you'll find the equivalent of that.
It would. The reason it's well, you'd struggle to get it to work with Power Query is it doesn't work in tables. So if you have Power Query pointing to a table, well, you just wouldn't get a dynamic array output, you'd get an error. But tables do expand on their own. So if you did have, like, you know, A1 plus B1 in a table, it would automatically go to the end. I guess they potentially could work with Power Query in some ways, would it not?
No, they wouldn't, because Power Query, anything you build in the back end has to work for the entire column. So
Yeah, but
you-
the formula will spill down in a table.
Yeah,
Oh yeah.
because anything that you do in Power Query, when you bring that back into Excel, it does come out as a table.
Mm.
So then you can just use all the legacy formulas because they will automatically drop down.
Oh, yeah.
When you refresh if you delete or do any changes, when you refresh your query again, everything will come back to what it was.
Yeah.
Thank you.
Anything else? Anyone online?
I think I'm on YouTube.
Yeah.
You should be able
That's
to
it.
hear, right?
Yeah, I don't believe so. Okay, cool. Well, if there's no other questions, thanks everyone for coming along, and yeah, hope you will learn something useful. Thanks.
Thank you.